well, here's the finished coil machine. It has the new outfitted wire straightener on it here. How it's fed is it's fed over the top, around the bottom, and then up over the top. Now the lower one is here and the upper one is here, and that's for the finer gauge wire. And that one moves very freely so that it makes the same tension on both wires. The felt cushion, I tried that method for a little bit, and what it was doing was giving me more tension on the larger wire than it was on the smaller wire. And when that happened, it caused the spool to not wrap completely correctly. And so what I found it necessary was to make sure that we had the both tension on both. So I got rid of the felt, and I went to this method here. We have our counter here. Now when I'm spooling, I found that I kept resting my hand here, but that's where I wanted to be able to look down to see where this was. So I just took and got a different calculator that's got a door on it, and I cut a hole through the door so that I can still see the figures, and this one's also solar, so that the battery always stays charged. So this is a one-time installation. I mounted our set switch here in the bottom so that I could do that really easily, and then I also have the start, the speed control, and then this wheel right here controls our feet. This is a close-up shot of the coil just as it's getting ready to start spinning. So you can see the importance of the two holes next to the core, and that enables you to get your wires as close over to the edge of the spool as possible to start your first course of turns. I have this set for a slow speed right now, but all I basically do is just add a little bit of pressure, and I'm just using the tip of my finger and my fingernail to put a little bit of added pressure on the side. And because of how smooth and both wires are tensioned at the same tension, it actually wraps very, very easily and very smoothly on the spool already. And we have 18 turns. That means that we have 18 rings of wire on our spool right now. And so if you're using the Vesper calculator, then you'll be able to see the two spools there. And you'll be able to see the length in footage, and you'll also be able to see the turns. Okay, this is just after the first row was complete and just starting back on the second row. Tension here. The tension is very, very stiff, and because the torque of our motor, that keeps us with a really tight coil on our core, and that's very important. We don't want to have any gaps or air density values that cause us to lose our flux rating from our core to our coil, and so it's really important that these all be consecutive and very tight. Side of our motor, you'll notice that I have a couple of wires coming off, and those two wires are actually for a power cell that I'm using, and that keeps the battery topped off while I'm running it. And the battery actually optimizes the amperage coming off of the power pack plugged into the wall. I've mounted some brackets here so that the battery doesn't move around and so it stays connected. And you'll also notice here on this side I've incorporated a fan. And what that does is that enables me to keep the motor cool and also our electronics cool, because I found that the motor was getting warm and I didn't want to burn out our motor at any point, even if it's 5 years from now. So the fan just added a little bit of protection as far as the heat goes on the motor. And over an extended period of time, I found that the circuit was getting a little bit warm. It wasn't hot, it was just warm, and I wanted to keep it as cool as possible to make sure that we had our running. Now, I also wanted to show you the foot counter, because there's a couple of things on that I want to show you. Okay, on our foot counter, you'll notice that I have a screw here with a washer. Underneath this washer is a spring, and that spring provides tension to our wheel, to our motor, where we rotate our spool from. And that makes sure that this always maintains contact and it won't slip. So that spring was necessary just to keep this here. And if I move this, you can see it moves kind of freely, but it's on that spring to keep tension for our wheel to our drive shaft, so that the motor won't spin at all. And as you notice, it won't turn. But you'll notice that the fan is actually on right now, and that helps bleed off excess current when I'm just pausing the motor by using the voltage control up here. And I recommend that you wire that into the same area as where you're bringing your motor out of. That'll help from overheating your windings in your motor if you happen to pause your motor without turning it off. And and you can see that the fan is on. Now if I simply turn this off, when I turn this off, it controls the motor, and it also controls our cooling fan, where you can see that it's stopped now. When I turn this on, our cooling fan automatically comes on, and our footage and everything starts to roll because our motor is on. Now if I turn this all the way down so that we stop our motor from rotating, you'll notice that the foot isn't rotating because our shaft isn't rotating, but our cooling fan stays on. And that helps to keep everything cool when we're not drawing any current off of our circuit. And that's a very important step in making this so that it'll run correctly, is you want to bleed off that excess power coming off of there. And that's why I have the fan ran in through the motor controller like this. You can get a zoom in on that so that you can see that in detail. And as you can see here, I've got 4 separate wires. This here, this one here, and this one here are all for our main wire, which is our larger wire. Then those same 3 plus the addition of this one, if I scroll down here to the side, just here, you will be able to see that smaller wire here. Okay? So all the wires rotate around the top, around the bottom, up over the top, and our large wire leaves the top here. Our smaller wire continues around and around the bottom one, and then up and through our block here. And then that goes to our spool. That's how all of this works. And it's very stable. I'm going to give you a top view of that, just so that you can kind of see it from the top. And again, you'll see our large wire on the side here and our smaller wire here. And these here are to protect our wire around the edge. So as our spool migrates left and right, it'll always make sure that we're in the center here so that it bleeds off here, comes into the center, follows all the way down to our coil. And you'll notice even though we were running, our coil is still nice and tight here. You'll notice that everything is still nice and straight. And I hope that that answers some questions, especially some of the emails that I've received on the motor unit and what to do if we start getting a little bit of heat buildup. And that's the best thing to do, is just wire your fan in through the motor control unit itself. And I hope you've enjoyed the video. And our next step is going to be testing out our coils that we make. And I'll show you all of that in a future video series. Thank you.